Welcome to today's episode of Math Dive in About 5. Today we'll be focusing on numerical expressions. My name is Barbara Knox.
And I'm Daryl Frost. Welcome.
Thank you for joining us. In just a moment, you're going to pause the video. You'll see several numerical expressions on the next slide that you're going to solve, and some of them have questions associated with them. Either complete the tasks on your own or with a team partner. You might want to compare after you've each done it on your own to see if you come up with the same solutions. As you're solving, consider the misconceptions that students encounter with order of operations, and also be thinking about why PEMDAS might create misconceptions for students. We'll see you back in a few minutes. Here we see the progression with BEST. You can tell that in first through fourth grade, they've done a lot of work with operations
and
equations. Equality, is it true, is it false?
That's that comparative relational thinking.
Determining unknowns.
So a lot and with variables. So before they get to that whole idea of evaluating expressions, thinking about order of operations, there's been a lot of work done with the equations and variables and unknowns in any
position. In fourth grade, they did write some equations that matched context.
Yeah, the notation is there as well.
You'll see all three benchmarks that this unit focuses on, but for our Dive in 5, we're going to be focusing on the order of operations, which is part of AR22.
So Barbara, go as I'm looking at this, and I think you were just talking about the vocabulary here. Yes. I read through these very quickly. I notice down at the bottom, that last sentence, it says grade 5 does not use nested grouping symbols. What does that nested mean?
So I can see parentheses, brackets, and braces in grade 5, but they're not going to be nested within each other. So I might have a set of parentheses here, a set of brackets here, but the brackets are not going to be inside the parentheses.
That would probably be more of a middle school idea where they see that.
Correct.
Okay, that kind of notation.
Yep.
Got it. I understand.
So now we're going to take a look at some of the tasks that you did in your first task slide. This was the first expression, and I can take any expression and I can turn the entire thing into addition only. So Daryl, I'm thinking about 6 groups of 4.
So I could think, oh, well, that's like repeated addition.
Correct.
I would write 4.
Add
4. 4 plus 4 plus 4 plus 4 plus 4 plus 4. I think that's 6 times.
Yes.
And that gives me 24.
And then I'm going to add a negative 5.
Or take away 5, which would be take away 4 from 24 is 20. One more would be 19 to take away 19, and then add 7.
And I get?
1 more is 20. I've made it 10, and then 6, 26.
So I've taken the entire expression and broken it down into addition. Once it's in addition only, I can solve it from left to right, and I get my sum of 26. With order of operations, you solve for multiplication and division first from left to right. There's only one multiplication symbol. There is no division, so we're going to solve 6 times 4 first. And then once I've solved that, I can move to the addition and subtraction. One thing that students quite often confuse, especially when using PEMDAS, is that they think addition needs to go before subtraction, but addition and subtraction are done simultaneously from left to right. And first I see what?
Well, I was just thinking, as you said, that the students having that misconception, I see 24 take away 5 plus adding 7. I could add 7 to the 24, get 31, and then take away the 5, or take away the 5 and then add the 7.
Okay, but what happens if I add the 5 and 7 first and then subtract?
That's if I add the 5 and the 7, that's not going to be correct.
Correct. That's going to give me an incorrect answer.
Yes.
So We have to do the subtraction in this case before the addition because it comes first when I'm
Right.
working from left to right.
Right. And context helps that a little bit too. They have
Correct.
situations where they can see that action.
So I still get an answer of 26
Yes.
using order of operations. Here again, I can turn this expression into addition only. So if I translate it into addition only, I've got 22 added to a -6. And then I'm going to add 9 groups of 1/3. And then I'm going to add 3 groups of 5. So translated into addition only, if I solve that, I'm going to get a sum of 34.
34, yeah. And that's it, because that's what 9 divided by 3 is.
Yes.
If you want to think about that as the inverse operation of addition, it's adding 1/3 9 times.
Correct. Using the order of operations, I'm going to solve multiplication and division at the same time from left to right. The first thing I see is 9 divided by 3, so I would solve that first, and then I would solve the 3 times 5, or the 3 groups of 5, and get my 15. So I've got, for 9 divided by 3, I get 3, and for 3 groups of 5, I get 15. So now my expression is down to 22, take away 6, plus 3, plus 15.
You're modeling something here, Barbara, I think is very important to think about with our instructional practice is you perform an operation or a couple of operations and then you notate where you are so that they're keep tracking what they've
done and what they haven't done.
Exactly.
Right. So now I've got just addition and subtraction. The very first thing I see is subtraction. So I need to do 22 take away 6 first. Then I need to add my 3. And then I need to add the 15.
Mm-hmm.
Regardless of whether I turn it into addition only or I use order of operations, I'm going to come up with the same solution of 34.
Exactly.
When you solved this expression during that first task, we asked you to think about why the parentheses were necessary here. So we're going to solve it both ways, with and without the parentheses. So with the parentheses, I have to perform what's inside those parentheses before I do anything else, and that gives me 25. Then I do my division. 25 is divided into 125, giving me a quotient of 5. And then I add the 16 to get a total solution of 21. But if the parentheses aren't there,
looks a little different.
It does. What do we do first here, Daryl?
Well, I'm going to have to multiply 5 times 5.
Am I going to?
Oh, excuse me. Yeah, the parentheses are not there.
They're not there.
They're not there. So I'm going to start with the division.
Correct.
So 125 divided by 5 is 25. And then I'm going to multiply that quotient by 5. That would give me 125. And then add 16. That's 141.
Those two answers are very different, right?
Yeah.
So those parentheses in that expression are necessary if I want them to multiply the 5 times 5 first. Here we see a typical multiple choice problem that a student might see on an exam or a test.
Mm-hmm.
So all 4 of those answer choices are reasonable if students have misconceptions. So there is a misconception associated with every single incorrect answer, and we're going to take a look at how students solve to get those solutions. So with A, Daryl, where do you see some mistakes in A?
Well, right away, I see on the if you're looking at the second line of values there, they should have divided before they multiplied. So they should have divided 72 divided by 6 and got 12.
And then multiplied
and
by
then
2.
And then multiplied by 2.
And there's also one other mistake in A.
Let's see here if I can see it. Let's see, they divided 72 divided by 12 and got 6. So then they, I see what they did. They should have subtracted 3 before they added because
So
they added
they
3 and
added
2.
3 and 2 together.
They added 2.
So A actually made two
Two mistakes.
to get to their
But
incorrect
I could see that
solution.
happening.
Yeah.
That's a good
Oh, yeah.
distractor.
B is very much like A, except that they did the addition and subtraction part correctly, but they made the same mistake with multiplying before they divided.
Yes. And that's what I meant to say on A.
Correct.
They should have divided first.
On C, they did divide first.
They sure did.
So what did they do wrong?
Well, let's see here. Let me think about this. They multiplied 12 and 2. They got 24. They should have taken 3 away from the 24. What they did is they added 3 and 2 again.
Correct.
Kind of like what they did in A.
Yes. So they fixed one mistake from A, but kept with the other mistake.
Yes.
And D is the correct solution. So you can see that all of those make sense if a child has a misconception about using the order of operations. Here we have an expression where students have to decide where to put the parentheses so that the value is 56. If there are no parentheses, the value is not 56.
And so I like these kinds of tasks, and I've seen these before, and I think these are difficult.
They are difficult.
So I think that like using the strategy of trial and error.
Right, I just have to move those parentheses around.
And then kind of pay attention to what does the value need to be? What did I get? Is it matching? If it's not, then okay, where would it make sense to? So you're kind of reasoning also. You're not just kind of like randomly putting the parentheses.
Right.
You're thinking it through. What was my answer? What do I need to get? And where does it make sense?
So here, right now, the value is 41. I know that 41 is not the correct answer. So I'm going to start by putting the parentheses around the two groups of 6.
Mm-hmm.
So if I do that, my expression has a value of 6 because I get a product of 12, and 12 divided by 12 is 1.
Right.
And then I add 1 to the 3 to get 4, and 4 to the 2 to get 6. That's going to give me a much smaller
number
than
value
what I want, right? I move the parentheses, and this time I include all of the addition inside the parentheses. So I'm going to add 6, 3, and 2 together. I get 11. Where do I have to start?
Well, so I add, like you said, I have 11. Then I have to 12 divided by 2 is 6, and times 11 would be 66.
So a little bit too much there.
A little bit, yes, but I am getting
closer, right?
Yes.
So now I'm going to try putting it around just the 6 and the 3. So now I have 9 inside the parentheses. Then I go back to multiplication and division.
Right. So if I have 9 in the parentheses, 12 divided by 2 is 6 times 9. 6 times 9 is 54, plus 2 is 56.
And I have my magic solution, 56.
Yes.
So now I know that's where the parentheses should go.
Well, I'm at a loss. Barbara, why do we not use this PEMDAS or PEMDAS? And please excuse my dear Aunt Sally.
I think when students use this acronym, they start with the P, then they go to the E, then they go to the M, then they go to the D, and the M and D aren't separate. The multiplication and division have to be done at the same time from left to right. So if division comes before multiplication, I need to do the division first. And if they're thinking about PEMDAS, they might think, oh, multiplication comes before division.
Gotcha. Yep. That makes sense, yeah.
So if you are going to use PEMDAS, you may want to write it a little bit differently in your classrooms. so that students know that multiplication and division get done together from left to right, and addition, subtraction get done together from left to right.
There you go. That's my.
Here is another acronym, GEMS, where we do all of the grouping symbols first, then the exponents, which we don't worry about exponents in 5th grade anyway. Multiplication and division together, subtraction and addition together.
So it's another way to think
Another
about
way
it.
to think about it. Here are 2 additional misconceptions. Sometimes students think they need to solve the entire expression from left to right. So it doesn't matter what operation comes where. I'm going to start at the beginning and I'm going to do one step at a time going from left to right.
We're not even thinking about like any kind of order.
Correct. And then with writing expressions, sometimes they forget to add parentheses when those parentheses are needed. They'll write the expression thinking it's going to give them the correct answer because it has all the necessary pieces, but the addition subtraction has to happen first, and without those parentheses being there.
So it's good for them to have practice where they have to actually notate the parentheses
Correct.
to get a certain value.
Yes. Thank you for joining us for this edition of Math Dive in About 5. We'll see you back next time.
Bye.